This is the second part of the X-ray machine series video. We will look into the application and controls in an X-ray machine. If you have not seen the first part, I recommend that you go and watch that part first. Let's look into the effect of changing X-ray tube voltage, also known as kVp control. kVp refers to the maximum high voltage applied across an X-ray tube during the creation of X-rays within it. During X-ray generation, surface electrons are released from a heated cathode by thermionic emission. The applied voltage accelerates these electrons toward an anode target, ultimately producing X-rays when the electrons are stopped in the anode. Thus, the kVp corresponds to the highest kinetic energy of the electron striking the target and is proportional to the maximum energy of the resulting X-ray emission spectrum. In early and basic X-ray equipment, the applied voltage varies cyclically with 1, 2, or more pulses per mains AC power cycle. One standard way to measure pulsating DC is its peak amplitude, hence kVp. Most modern X-ray generators apply a constant potential across the X-ray tube. In such systems, the kVp and the steady-state kV are identical. kVp controls the property called radiographic contrast of an X-ray image, the ratio of transmitted radiation through regions of different thickness or density. Each body part contains a certain type of cellular composition which requires an X-ray beam with a certain kVp to penetrate it. The body part is said to have subject contrast, that is, different cellular makeup. Some dense, some not so dense tissues, all within a specific body part. For example, bone to muscle to air ratios in the abdomen differ from that of the chest area. So the subject contrast is said to be higher in the chest than in the abdomen. In order to image the body so that the maximum information will result, higher subject contrast areas require a higher kVp so as to result in a low radiographic contrast image, and vice versa. Let's know about milliampere seconds, or MAS, control in X-ray machines. Milliampere seconds, more commonly known as MAS, is a measure of radiation produced milliamperage over a set amount of time seconds via an X-ray tube. It directly influences the radiographic density when all other factors are constant. An increase in current MA results in a higher production of electrons that are inside the X-ray tube, which will, therefore, increase the quantity of radiation. More radiation will cause more photons reaching the detector, and hence apparent structural density will increase, yet the signal intensity will increase. The time factor is a measure of the electron's production duration in the tube, meaning prescribes how long MA will last. The reciprocity law states that a reaction of photogenic emulsion to light will be equal to the products of the intensity of that light and the time of the exposure. This law pertains to MAS in the sense that all combinations of MA into T that amount to an equal quantity will produce the same amount of density. Let's look into cassette in X-ray machines. A flat, light-tight container in which X-ray films are placed for exposure to ionizing radiation, and usually backed by lead to eliminate the effects of backscatter radiation. The structure of a standard cassette suggests a book, as it consists of two flat rectangular plates hinged along one edge. The front aspect of the cassette faces the X-ray tube and consists of a sturdy metal frame into which is fixed a sheet of either light metal such as aluminum or plastic material, the critical point being that it must be transparent to X-rays. The frame constitutes a shallow container into which can be placed a thin intensifying screen and film. The back of the cassette is constructed from a strong metal. It is customary to spray the internal surface of the back of the cassette with lead paint, the purpose of which is to absorb secondary radiation scattered back onto the film. Backscatter the back of the cassette contains a felt pad. The intensifying screen at the back of the film lies on this felt and is usually glued to it. The function of the felt is to maintain this screen, the film, and its fellow screen in uniform, firm contact. The front and back of the cassette are held tightly together, either by spring clips on the edge opposite to the hinge, or by means of pivoted, resilient metal bars on the back of the cassette which fit into grooves in the frame. Let's know what a bucky is in an X-ray machine. A bucky is typically used for table or wall-mounted X-ray systems and holds the X-ray cassette in grid. A bucky is a device found underneath the exam table, a drawer-like device that the cassette and grid is slid into before shooting the X-ray. There is nothing special about a bucky grid other than its size. A reciprocating bucky is a device that moves the grid while the X-ray is being taken. The motion keeps the lead strips from being seen on the image. The finer the lead strips, the less movement is needed. Let's wrap up with X-ray detectors and X-ray films. Perhaps the most common type of X-ray detector uses an electric current to measure incoming X-rays. In this type of detector, an X-ray interacts with a material freeing an electron. That electron can rattle around in the detector and give energy to other electrons. In some materials, these electrons will have enough energy to be freed of their host atoms. In that case, applying an electric field will allow those free electrons to be collected and counted. The number of electrons collected tells you the energy that was deposited. In the case of X-ray film displaying the radiographic image and consists of emulsion, single or double, of silver halide, silver bromide is the most common when exposed to light, produces a silver ion and an electron. The electrons get attached to the sensitivity specs and attract the silver ion. Subsequently, the silver ions attach and clumps of metallic silver black are formed. The silver can be reclaimed from an old X-ray film in a process known as silver recovery. This was the basics of each X-ray machine in radiology. There are n number of techniques used to diagnose the patient with X-ray, but the basics are used the same in all different types of X-ray machines. I hope this series helped you to understand how really an X-ray machine works in a simplified manner. Thanks for watching Biomedical Engineers TV. See you guys in the next video.